sliding contact of a potentiometer is in the middle of the potentiometer where having resistance Rp is equal to 1 ohm as shown in the figure. An external resistance of Re equal to 2 ohm is connected via the sliding contact. Find the total current flowing in the circuit. So here the sliding contact of the potentiometer is in the middle of this resistance Rp is equal to 1 ohm. So if we draw this circuit again, that is the 0.5 ohm, that is if we divide this part 1 ohm into 2, because the sliding contact is at the middle, so the resistance will be divided in two parts, 0.5 ohm and 0.5 ohm, and the contact is connected in between, that is here. So this value is 0.5 ohm, this is 0.5 ohm, and here an external resistance is connected of 2 ohm Re, and a battery is connected here of value 0.9 volt. 0.9 volt. We have to calculate the total current in the circuit, that is I, the current flowing through the battery. Now the resistance, that is the total resistance of the circuit, let's say this point is A, this point is B, and this is C. So the equivalent resistance between A and C is, so 0.5 and 2 ohm are in parallel. Now we know that 1 by R is equal to, that is 1 by RAC is equal to 1 by 2 plus 1 by 0.5, or RAC is equal to 2 into 0.5 divided by 2 plus 0.5, that is 2.5. Now if we calculate this, 0.5 times 5 and 2 by 5 is 0.4, that is 0.4 ohm. So between A and C is 0.4 and C and B is 0.5. So the total resistance of the circuit R becomes 0.4 ohm plus 0.5 ohm, that is 0.9 ohm. So now if we draw the circuit again, that is the battery is of 0.9 volt and the equivalent resistance between A and B is 0.9 ohm. So 0.9 ohm. So this is 0.9 ohm. So the current I will be V by R, that is 0.9 divided by 0.9 volt by 0.9 ohm, that is 1. 0.9 by 0.9 is equal to 1 ampere. So the current flowing through the battery is 1 ampere. That is here option 3 is the correct answer. Thanks for watching this video. Please like this video, subscribe my channel and share